Okay, guys, we have a composite list of all your exponent rules. Some of these you've been using since Algebra 1, like for instance, the product rule here, power over power rule, quotient rule right here. These are the probably relatively new. You may have seen these in algebra. Hopefully you did. Okay, we've been talking about all these in class, and so it just comes back to spending time putting ourselves in situations where we have to apply these rules. Okay, so let's see, right here. All right, some of these are incredibly easy to do. Okay, so let's take a look here. Okay, right here, the 1/2 power of 144. That's real easy. Okay, because remember, 1/2 power means square root, so that means the square root of 144. And we know that 12 squared equals 144. Okay, so the square root of 144 is just 12. Okay, no big deal. Okay, second one down there. Well, notice it's a negative number. Okay, but it is an odd root, so we can take the odd root of a negative number. Okay, so this means the 5th root of negative 243. Okay, now if I remember right, 243 is a perfect 4th power. If I remember right, okay, I'm sorry, perfect 5th power. 3 to the 5th is 243. There we go. I remember that one off the top of my head. So we know that negative 3 to the 5th would give us negative 243. Okay, so the 5th power of negative 243 is just negative 3. Okay, so easy stuff there. Okay, positive number, even root, works out. Okay, so we have the 4th root of 1,000. I'm sorry, 10,000. My fault. Okay, if I remember right, I am pretty sure that 10 to the 4th is 10,000. It most certainly is. Okay, so 10 to the 4th is 10,000. Okay, so the 4th root of 10,000 is just 10. 1, 2, 3, yeah. Okay, so we're good. Okay, so these guys right down the left-hand column are pretty easy. Okay, these get a little bit tougher. Okay, because notice over here in the fractional exponents, the numerator is 1 all the way down, so it makes life easier. It's just a square root, 5th root, 4th root. Over here it's different because notice the numerators are not 1. Okay, so that would mean the 5th power of the square root of 200. This would mean the 2nd power of the cubed root of negative 125, and this would mean the 7th power of the 4th root of 729, so a little bit more work. Okay, so why don't we take these one at a time? Okay, and I might need a little bit more room here. Okay, so we have 200 to the 5/2 power. Okay, that is the same as 200 to the 1/2 power raised to the 5th power. Okay, and I sort of like to work with this. I like to take the root, the denominator, the 2, and break that guy down first, and then I'll apply the 5th power. So let's see. 200 to 1/2 power, that means the square root of 200. And then I have to raise that to the 5th power. Okay, so let's take 200 and let's put that in simplest radical form. Okay, so square root of, so let's see, 200 is not a perfect square, but the largest factor of 200 that's a perfect square is 100. Okay, all right, so let's see, the square root of 100 is 10, so that just gives me 10 times the square root of 2 to the 5th power. Okay, so that's going to give me 10 to the 5th times square root of 2 to the 5th. Okay, so let's see, 10 to the 5th is just a 1 with 5 zeros after it. So that's 1, 2, 1, 2, 3. So that's 100,000. And then I'm looking this. Well, remember, if you multiply a square root by itself, you get the radicand. So if I break that up, I have 5 of them. So if I pair up square root of 2, if I pair up 2 of them here and 2 of them here, notice I still have one more factor of the square root of 2 left over. Okay, so I have that 100,000 out front. Well, when I take square root of 2 and square it, I just get 2. Same thing, square root of 2 and square it, I just get 2. And then I have this radical 2 down there. Okay, so let's see, this would be 4, so 100,000 times 4 is just 400,000. So I'm going to get 400,000 times the square root of 2. All right, we're in good shape there. Okay, so that takes care of that guy. Let's go down to the next one. Let's see what we got going on there. Okay. All right, so I have negative 125 to the 2/3 power. Okay, again, I know that denominator 3 means cubed root. Okay, so if I take negative 125 1/3 and then take that whole thing and square it. Okay, now 125 is a perfect third power. Okay, so I'm going to have the cubed root of negative 125, and then I have to square that. Well, 125, that's 5 cubed, so negative 125 would be negative 5 cubed. Okay, so the cubed root of negative 125 is just negative 5. But then I have to square that. So negative 5 times itself will give me a positive 25. Okay, so we're good there. That one was pretty easy. Okay, and then we get down to this guy, which is a little tough. Okay, so let's see. We have 729 to the 7/4 power. Okay, so I'm going to sort of do the same thing. So I'm going to take the 4th root of 729, and then after I'm done, I have to raise that to the 7th power. All right, now 729 is not a perfect 4th power, but I'm pretty sure 729 has a factor of 81 in it. Okay, so let's go 729 divided by 81. That's 81 times 9, and 81 is a perfect 4th power. Okay, so let's start there. Okay, so I have the 4th power of 729 is 81 times 9. And I'm going to take that to the 7th power. Okay, so let's see. 81 is 3 to the 4th, so the 4th power of 81 is 3. Okay, so I'm going to get 3 times the 4th power of 9, and then I have to raise that all to the 7th. Okay, so let's see what we got going on here. Okay, so I'm going to have 3 to the 7th, okay, and then I take the 4th root of 9 to the 7th power. Okay, 3 to the 7th, let's see, that's got to be a relatively large number. 3 to the 7th power, 2187. Okay, so that's 2187 times, okay. Well, if I could take the 4th root of 9 and raise it to the 4th power, I just get 9. Okay, so if I do that, the 4th root of 9 to the 4th power, notice I still have 3 more factors of the 4th root of 9. Okay, so we get the 4th root of 9 to the 3rd power. Okay, let's see what we can do there. Okay, so I get 2187 times, let's see, the 4th power of the 4th root of 9 is just 9. Okay, now I'm looking at this guy. Okay, well, isn't 9 3 squared? Okay, so couldn't I consider that to be the fourth power of 3 squared cubed? Okay, well, let's see. Let's take 2189 and multiply it by 9. Okay, so 2189 times 9, I'm getting 19,683. So that's 19,683. And then I'm looking at this guy. Well, if I bring this 3 on the outside and bring it underneath, would I multiply the 3 and the 2? Okay, so I'm going to get the fourth root of 3 to the 6th. Okay, so I could take the fourth root of 3 to the 4th. Okay, so I got that 19,683. And then I'd have the fourth root of 3 to the 4th times 3 squared. Okay. Well, the fourth root of 3 to the 4th is just 3. So I get 19,683 times 3 times the fourth root of 3 squared. Okay, so if I take that 19,683 and multiply by 3, I'm going to get 59,049. And then the fourth root of 3 squared I can't do anything with, so I'll just write it as a fourth root. 3 squared is 9. And we're done. Okay, so that one really takes some work there. Okay, you got to work at that one. That one's a little bit tougher. Okay, so those guys go by the wayside. Let's see what we got going on here. Okay, so let's start up here and let's see what's going on. Now notice I have the base of the numerator is 9 and the base of the denominator is 9. So I can use the quotient rule here. That would be the same as 9 to the power of 5, 6 minus 1/3, like that. Okay, so let's see, 5, 6 minus 1/3. Well, 1/3 is the same as 2, 6. So I'd have 5, 6 minus 2, 6, which gives me 3, 6. And isn't 3, 6 just 1/2? So 9 to the 1/2. Well, 1/2 power means the square root. So that's the square root of 9. So I just get 3. Okay, so that one's okay. That one wasn't bad at all. Okay, let's see what happens here. Same thing here. The base in the numerator is 8. The base in the denominator is 8. So I can apply the quotient rule. So we get 8 to the power of 2 minus 1/2. Okay, so 2 minus 1/2 is 1.5 or 3/2. So that's 8 to the 3/2 power. Okay, so I can take a look at, that is the square root of 8 all cubed. Okay, when we put the square root of 8 in simplest radical form, you get 2 radical 2. So that's 2 radical 2, but that's cubed. Okay, so I would take the 2 out front. I'm sorry, I'm writing a 3. I would take the 2 out front and cube that, and then take the square root of 2 and cube that. Okay, well, 2 cubed is just 8. We know that. And then notice this, I have 3 factors of radical 2, so that would be like radical 2 squared times radical 2. Okay, so let's see, 8 radical 2 squared, I just get 2, so that's 8 times 2, so that's 16. And then I have that radical 2, or square root of 2. There's nothing else I can do with that. Okay, all right, so we're okay there. Okay, let's see, once again, just like these two, I have the same base in the numerator and denominator, and that's 32 to the first. Okay, so we can go 32, and if I take 5 fourths minus 1. Okay, so 5/4 minus 1, that's 5/4 minus 1/4, okay? I'm sorry, that's 5/4 minus 4/4, which gives me 1/4. So I get 32 to the 1/4 power. Okay, 32 is not a perfect fourth power. Okay, so I'm going to get the fourth root of 32. Okay, but 32 does have a factor that's a perfect fourth power, and that's 16. Okay, so we get the fourth root of 16 times 2. Well, 16 is 2 to the fourth, so the fourth root of 16 is just 2. So I'm going to get 2 times the fourth root of 2, and there's nothing else I can do there. Fourth root of 2 is the fourth root of 2. Okay, so we got those three. Those weren't too bad. Okay, so let's take a look at these guys. Okay, once again, applying the quotient rule, 25, okay, and then it'd subtract the exponents 5/8 minus 1/8. Okay, so that's going to be 25 to the 4/8 power. And 4/8 reduces down to 1/2, so that's 25 to the 1/2 power. So that's just the square root of 25. And of course, 25 is a perfect square. Square root of 25 is 5. Okay, so that's relatively simple. Okay, let's go to this guy. Okay, once again, 12 is the base in the numerator and denominator, so I can apply the quotient rule. 12, let's see, we go 3/2 minus, that would be 12 to the first, so it'd be 3/2 minus 1. Okay, so 3/2 minus 1 would be 3/2 minus 2/2. Okay, so I get 12 to the 1/2 power. So that's just the square root of 12. And of course, we have a factor of 4 in 12, and I can take the square root of that, so when I put square root of 12 in simplest radical form, I get 2 radical 3. Again, relatively easy one again. Okay, so these guys are both okay. So something tells me this guy's going to be a little bit tougher. Okay, so let's see what we got going on. Okay, applying the quotient rule. So I have 40 to the power of 7/3 minus 5/3. Okay, so I subtract those exponents and I get 40 to the 2/3 power. Okay. Now let's see, that is the cubed root of 40, and then I would have to square that. Okay, this one isn't bad. I mean, it's certainly not as bad as some of the other ones we've done. Okay, so let's see. 40 is not a perfect cube, okay, but it has a factor that is a perfect cube. 8 is a perfect cube. Okay, so let's see, this is the cubed root of 8 times 5, and then I have to square that. Okay, so let's see. The cube root of 8 is just 2, but I can't do anything with the cubed root of 5. Okay, so let's see, I have to take everything underneath there and square it. So I get 2 squared times the cubed root of 5 squared. Okay, so 2 squared is 4. And then, let's see, I can't do anything here because I only have 2 factors of the cubed root of 5. I would need 3 or more. Okay, so that is just going to be the cubed root of 5 squared, or 25. And that's all we can do. Okay, so we're in good shape there. Okay, I like those. Those aren't bad. Okay, so I am going to shut down the first video, okay, and I'll get that uploaded, and then we'll make some more.